Okay, thanks a lot everyone for coming. I know it's the last talk, you're all tired. You want to go and have a beer probably and not see code on a gigantic screen here. But it's going to be quick, I hope that engaging and fun. Original, of course, this talk is about animations. Have a years of experience on working on applications that have heavy animations and view transitions in React applications. But it's also a story based on a real production project that I had to do, and so I'm gonna show you some mistakes that I made and lessons you can probably take to your daily job. As Caroline said, quick introduction about me. I'm Jeremias Menichelli. I'm pronouncing my name that way because I'm from Argentina and that's how it's pronounced in Spanish. But I'm currently living in Barcelona in Spain, working at Typeform at the design system. Yeah, design system team at Typeform. Those are a bunch of useful URLs. Most of the material that I'm going to present today is going to be here, so feel free to check out after. So yeah, the fun fact is that you see that all the React Development speaker has this cute avatar that is amazing, and we were all like blown out when we received on our emails. And so I was surprised that mine had this dog. Of course, this is my dog, and she's like really cute, and she's the best dog ever. But she's back in Argentina living with my mom. So yeah, so that's all about me. Summary that we're gonna see today. So first we're gonna talk about routing and views in React. Just super quick example and explanation. Then we're gonna go through React Transition Group, which was the package that we use back in my previous job to do this animated experiences. And then we're going to try to combine them together to see how we can create these view transitions and create specifically a custom transition per each view that we have on our application. Then we're going to talk about kicking transitions on first load, which is not as easy to do, at least around performance. And then we're just going to wrap up and go with some conclusions. So let's start with routing, and we're going to use React Router DOM because it's kind of like the most used package out there. Can you raise your hand if you've used React Router in some projects? Okay, most of people. So it's gonna be quick. I'm not gonna like try to explain the whole API. I'm just gonna use the browser router component, the switch component, and the route component. And like, super simple and short example with something like this: that you have your application, you have a navigation, and you just wrap everything in a browser router component, and you have a switch component, and then in this case just 3 routes. The browser router component is gonna handle the logic around the location of the browser changing over the time of your location, and then you have switch, so it's gonna decide which route should render based on the path that we're passing, and then we pass a component with the actual content. So assuming that we have real content in this application, should look something similar to this. We have a navigation, we have content at the bottom, and every time that the user clicks on a link, you see different content from each component. So that's for routing. For transitions, I'm going to show you React Transition Group. React Transition Group has a shorter API. Actually, just comes with 3 components: the transition group, the CSS transition, and the transition component. And again, we're going to go through like quickly to see how they work together. So let's say that you want to create a transition for the React component that is like getting mounted on your application, and you want to use CSS, so you're going to use the CSS transition. But first, you need to wrap everything in a transition group component. And then inside that transition group component, you basically toggle this component. Every time that it can be from a prop, it can be from a state, something that's going to change over time. And then you wrap that component, in this case it's pop-up, and you wrap it in a CSS transition, and you pass a class names string and a timeout. So basically what's going to happen is that every time that this open changes, let's say that to false, and this component will be unmounted. So we're gonna get a toggle of class names on the root element of pop-up, and we can use them to animate. So in this case, let's say that the element is living, so we're gonna get a because I'm using fade, so it will be like fade exit, then fade exit active when the transition should trigger, and then fade exit done when the transition should end. And the same with enter. We're gonna get like fade enter active, fade enter done. And want to use CSS transition, it's just this, and then you have like a fade-in animation. It's that simple. This is also really useful for multiple elements that are sharing the same animation, because your CSS won't scale at all. You just need to like map, in this case, the elements, and you map each item with a CSS transition component, and you pass a key as with the index. and that's it. And you can use the same CSS as before. And this is actually what we're doing on the design system at Typeform. We're like basically distributing an animate component, and you can pass as many change learn as you want. And we have a predefined set of CSS transitions that you can use. So it's pretty useful. The element that I'm more interested in for you to know today is that transition component, and that is basically the same. The example is super similar to the one that we previously saw. The difference is that now nothing happens unless we actually do something with JavaScript, but we now have an enter and an exit hooks. We can pass a function there and do something with the JavaScript library, do some calculations, and do probably more complicated animations that maybe they're not possible with CSS. So this is it for routing and transition. You can see that the APIs are pretty simple. I really like them, to be honest. I really like. There used to be like a previous version of both, and I mean, you get used to them, but they weren't like as clear when you were reading them. And these new APIs are amazing. I really love them. The problem is that now combining them is way harder. So actually, I was using the previous versions on my project. And now I needed to relearn these APIs for the talk because I didn't want to show you like legacy code, and it gave me a lot of headaches. But it's possible; it can be done. It's not impossible, and I'm going to show you how. So when we finish, we should see something similar to this. We have the previous application, but in this case, you will see that each route enters in a different way. You have an about and an author page, and then we have the home, and the home page has this sleek like staggering by each line, and then when you go to about an author, you'll see that first it comes the title and then the content. We have different DOM elements inside of each view, and for that we want like different animations for each. So how we do that? So we need to kind of like intercept our routes with CSS transition and or transition components, and it's not easy. So we're gonna go back to our previous code and see this is the logic that we have to manage the routing. And we're going to concentrate in the switch part because this is a part that's going to get changed, actually. And the problem with this is that I can interpolate transition components in the middle of the route, as you might try to do. And the problem is that if we do that, then we completely break the logic for React Router. It's basically switch expects routes as children, and the same will happen with transition group and transition or CSS transition components. They expect to be direct children, so you're gonna have an issue with that. We're gonna do a super small change to this, super small. It actually won't change much. Just 1, 2, 3, this. So you see that we just wrapped everything in a route component, and we're passing out a render prop with a function, and we're just passing the location to switch, and nothing has changed. That our application is doing the same as before. The clicks changes the views, and that's it. The difference is that every time that the location changes on the browser now, we're going to be in control of what it gets rendered every time that this happens. Something that we were like relying on React Router before. So now we can do something inside this function and say, hey, maybe we can change something, calculate something, I don't know. So now we can wrap everything in transition group and transition component and apply our animations. So yeah, I know this is a lot of code. Let's go line by line. I swear it's much simpler than you might imagine. First, I'm extracting path name and key from location, something that is provided by React Router. And then we're wrapping all of the switch in a transition group and then a transition component. And you will see that I'm passing a key, this unique key that is provided by the browser router component. And this is important. Is all of you familiar with keys in React? Can you raise your hand if you understand keys in React? Okay, it's good. It's a good amount of people. Anyway, I'm going to go like super quickly over them. So keys, usually we don't need them. React like takes care of kind of like tracking each element and patching what is needed to be changed on the DOM. But if we want to force the remount of an element, like doesn't matter if the prop has changed or not, we can just change a key on the component, and the component will completely unmount and be remounting again. And this is pretty useful because every time that the location changes, we want the transition to be unmounted and remounted again. So we're going to basically trigger this because we can use a boolean here. So we're going to trigger this with a key. So every time that the location changes, now our transition component is going to get remounted, and the onEnter hook that you see there is going to get a call, at least the callback that we passed, and we receive the node with the root element of the view, and we can do anything that we want with any JavaScript animation library. So I'm having, in this case, an enter function. If we go inside of it, you see that I'm using the path name that I was extracting before. And I'm saying, hey, you know, if the path name is the home, then give me the home timeline. And if not, then give me another timeline, in this case, the default one, and then play it. So it's not a huge deal. And if we get inside this get home timeline and get default timeline, we will see the animation that is happening. I'm slowing down the home animation so you can understand it, but you see that each line gets like entering from the left and an opacity. And the animation will look something like this. You see that in this case I'm using GreenSock, but you can use any JavaScript animation library that you prefer. I'm creating a new instance of a timeline, but paused because I don't want it to be immediately execute. So I'm then grabbing all the text nodes, and then I'm applying these animations to the timeline, and then I'm returning the timeline, and the enter function is the one that is gonna call it. The same for the default timeline. You see that first we have a fade in, and then the containers appearance from the bottom. And this is a little more complicated animation, but it's not that complicated either way. You see that now I'm extracting the container, the content inner, and the content of the node. I'm doing a fade in, and then something, maybe a little trick that I can show you is that instead of animating the whole container, I'm first animating the container without the content and then fading in the content. What happens is that when you're like animating a really big node, the browser like really lags. So it's a little neat trick, and it doesn't like degrades the look and feel. So that's how you implement transitions. So now that you have kind of like a recipe, you can do it. If you have an application using React Router, you can just look at the code and apply your animations with CSS or with a JavaScript animation library. But the actual reason that this talk exists is we have a really bad problem with performance. Because one designer comes really close to release and say, hey, you know, I'm just looking at the homepage on the staging server and it looks really bad. And it was a performance animation. So basically, when we were getting the application rendered, the first animation, doesn't matter the route it was like really bad, really bad. So this is clearly a performance issue. So I tried to work around it and see what I could do. And the first try was to move the animation to the next frame. So basically, instead of executing in the same thread as I was executing the first mount of the application, move it to the next one. So you can use RequestAnimationFrame. I don't know if you're familiar with it, but it's native. It comes with the browser. And basically, RequestAnimationFrame, you pass a callback, and that callback is going to get queued in the thread of the paint thread of the browser. And that's kind of cool, because if we're doing actually like moving pixels around, we better do it in the paint thread, where the browser is kind of optimizing that. If you want to hear more about JavaScript threads and RequestAnimationFrame, Jake Archibald did a really great talk about this. Like, it's amazing. Helps you a lot to understand threads in JavaScript, and particularly RequestAnimationFrame. So back to us. Let's move this this timeline plate to the next frame. Super simple. You just create a new function with a timeline play execution on it, and you pass it to RequestAnimationFrame. And that's it. We pass the timeline to the next frame. Yeah, but it didn't work, of course. I was like still executing the application on staging, and it wasn't working, because it's web development, so it's never easy. Yeah. So my second try was to actually move it after the next frame. And I know it sounds kind of stupid, but I have a reasoning, because actually the next frame of the execution is the one that the application is actually getting rendered, and I'm the one after that. So how you do this? Well, super simple. You just add another RequestAnimationFrame around it, and you're done. Yeah, job done. Super smart. But of course it didn't work. I was like pushing to staging, doing a full reload, still getting the performance issue. So I said, okay, other thing that I know is browser hints. I don't know if you're familiar with it, and I'm gonna ask you again to raise your hand if you know will change property in CSS. Okay, now keep it up. Keep it up if it was useful to you at least once. Okay, really? It was useful to you? I want to hear that then. Because basically, for the people that doesn't know will change, you're not missing that much, in my opinion. Basically, you're applying this will change transform to an element, and the browser will kind of know that you're about to do some heavy tasks around animation and transforming on top of that node. So the browser will optimize that node for that animation. The problem with will change is that right now we're living more in a declarative world with React, and will change is just an imperative thing. Is that you just put a property there. By spec, the browser needs some time to run these optimizations before we can run the animations. But it's a CSS property. When do I know that the browser is ready? Actually, by spec, the browser can bail out from doing any optimizations. How do I know that the browser actually decided to bail out? So I maybe don't run the animation. I can do something more smart. I don't know. To me, I have a experience with dealing with a lot of heavy animations, and will change. To be honest, didn't came with any help. So to me, will change is basically a broken promise. Sorry. So my fourth try was to actually change the animation method we were using a lot from to, which is a method from Greenstock. And the problem with that is that it needs to calculate the starting point and the ending point. And it's a lot of computational heavy stuff going on. So I decided to move everything to from. And of course, it didn't work because it was based on nothing. And I don't know why I did it. It took me a lot of time. And by the time that I did this, it was already like 6 p.m. and I was super frustrated that I couldn't solve anything. And I was really really angry. So this is another piece of advice that I can give you. When you don't get any better idea and you know what to do and you're frustrated, just walk away from the screen. It's fine. Just go home, grab a glass of wine, and relax. It's fine. It's completely fine. Try not to spill that much, especially if the wine is good. People, please. I'm gonna get mad. But yeah. After that, and after taking a bath, of course, I decided to go with my fifth try. This was on the next morning, and I was already more relaxed and with a fresh mind. And I say, actually, let's start by profiling. If this is a performance issue, why I don't open DevTools and see if I can catch something up. So I decided to open and actually found something, because you can see here that we have the animation there, and you have a blue line and a red line in the middle of it. So the blue line and the red line indicates the load event and the DOM content loaded event of the browser. So if it's the first load of the application and these lines are not in the right position, you should really consider this as a possible issue on first load, especially around animations. Why? Because if these elements haven't been fired, it's because the browser is to updating the DOM and the DOM tree, or doing some heavy parsing on the initial resource that we're passing to the document. I definitely don't want to run the animation while this is happening. It's an easy way to hit the performance around the animation. So ideally, we will like the animation to be after these lines. So how you do it? Probably add event listener. So you could wrap your requestAnimationFrame timeline play in a window add event listener to load, and that's it, and it's gonna get executed. No, never do this. Poop. Why? Do you have a problem with this? The problem with this is that you will have a race condition issue. If for some reason the load event happens before you declare the listener, then that function will never get called, and your content will be empty, and we don't want that. The other problem is that this is not reusable. If let's say that not only you have this animation for the view, but you also have a header animation, you have a cookie banner, sadly, or a pop-up saying to subscribe. Don't do that too. But in case you have a lot of animations running on the first load of the application, you will be just wrapping up event listeners all around your application and hoping that all of them get queued before the event loads. And this also can bring a lot of issues on maybe browsers that don't handle async and defer scripts in different ways. So don't do this. The way to solve this, at least in my side, was to use promises, because promises are for that, are for async situations and concurrency. So we can basically queue something and react to it, and if we expose it globally, we can actually access it from different parts of the code. So it was a surprise that I remember doing something similar, and then I went and I found that I wrote something about wrapping stuff with promises. That was a really weird moment, and I actually wrapped, for example, a function to load a script on an async manner using a promise, and then I did the same with the style sheets. And of course, the things that we actually want right now is to wrap an event on a promise. And you see that it's not complicated at all. It's actually just 3 lines. We're basically creating a new promise, and we're resolving it and passing the callback as a listener. And that's it. You can place it on the head of our document. You can place it on a script before your bundle, that will absolutely make sure that this is never gonna get called because the browser has at least one resource to parse. And then you can use this window load promise global in any part of your code, for example, before the timeline play, and you can use it and you can reuse it across any part of your application. So you might think, but did this actually solve the issue? Well, it did. Because if you see now, the animation is actually happening after these 2 lines. And of course, I checked on the staging server and the performance issue was solved. And I was really happy. So the next question is that, should we do this on our applications? Like, should we, like, if we have some animation, some transition, or any heavy logic happening on the first mount, we should like go and create this 3-line thing and put it, because you have some guy passing like slides and saying that it worked somehow. So again, nope. Don't do it. Maybe it will work for you. It worked for me. It's working right now somewhere in production. But the take that I want you to think about and to probably put it in practice in your daily job is to actually profile your applications. When you have some performance issue, and even if you don't have, but you have some spare time, please let's open DevTools, see if everything is going well. And if we're doing some change to fix something around production, let's base it on metrics and findings that we have then, so you don't go through what I did and that I doing like first try, second try, third try, nothing happening. So a bunch of recommendations if you're thinking about applying animations in your applications. Things that I learned is that when an animation is happening, nothing else should be happening. So if you have some parsing, heavy logic, I don't know, anything, try to push the animation after that, because animations and performance get like really easily hit by anything happening on the browser. And if you can't do it for some reason, you say, hey, you know, I'm doing this or I'm trying this other technique and nothing is happening, just remove the animation and just show the content. Your user will love it. Testing is slow on older devices. Like not everyone has like a MacBook Pro and the last iPhone XS Pro, super expensive, and you might wish for the animation to look like pretty on all devices and for all users. Tweak your instance durations and delays if you see that performance is good but the animation is not looking good. I saw this a lot of times, that the performance was okay but the animation didn't look good, and so try to pair with some designer or some motion designer if you have that resource in your company. If you can use CSS, in my case it wasn't always possible because we're really trying to orchestrate really complicated timelines. But if you can, for some reason, go ahead with it. And again, I'm going to repeat it. Please, let's profile our applications and base our improvements on performance on metrics. So resources for this end-to-end. This application that you saw on the GIF is actually available. If you couldn't catch all of the code, it's on GitHub. You can like fork it, clone it, play with it. This promise-based initialization article that I wrote before, probably you will understand better why I did it. You have React Redon documentation around transitions. Was pretty good when I needed to relearn these new APIs. I used it. It was really useful. And you have also React Transition Group documentation. It's not that nice, but it's there. Check it out. And that's it. Thanks a lot.